Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on Francis turbine. So in our last few lectures, we have discussed about the working principle of Francis turbine, and we have solved the work done, how to calculate the work done, and how to draw the velocity triangle in the Francis turbine also we have done. So based on that, we'll solve this problem. A Francis turbine is an overall efficiency of 75% is required to produce 148.25 kilowatt power. So the Francis turbine with efficiency of 75%, it need to produce a 148 kilowatt of power. It is working under a head of 7.262 meter, and the peripheral velocity is given 0.26 root over of 2 gh, and radial velocity of flow at inlet condition is given 0.96 root over of 2 gh. The wheel runs at 150 rpm, and the hydraulic losses in the turbine are 22% of the available energy. Assuming radial discharge, calculate guide blade angle and wheel vane angle at inlet condition, and diameter of wheel at the inlet condition, and width of the wheel at inlet condition. So all the things we need to calculate the inlet conditions only. And for this problem, just we have drawn a diagram so suppose this is the plate is there. This is the plate or vane, or we can say bucket also. So in this, the jet is striking with a velocity of absolute velocity of here at this v1, and that velocity component is given in vw1 and vf1. Okay, and this is the velocity of the blade, which is given u1 at the inlet condition when it is moving in this directions. This is here the inlet velocity diagrams, and this is outlet velocity diagram. So these are the things already we have discussed in our previous lectures, like when the absolute velocity will make an angle of velocity of the wheel with an angle of alpha. Okay, and this is our relative velocity VR1, which makes an angle of theta with respect to the blade velocity. And this is the VF1, which is the wheel velocity, or we can say the vertical component of the V1. Similarly, VW1 is the horizontal component of V1. Okay, and this is the outlet condition triangle is there, where you can see the radial discharge is given. So radial discharge in the sense there VW2 will be 0. Okay, so actually the velocity triangle we have seen, it is to given in this way, but here it is given the discharge is radial at the outlet condition. Okay, that means radial discharge in the sense when it is radial discharge is there, this VW2, this is our VW2 at the outlet condition. This is V2. Okay, and this is beta. This VW2 will be 0 when it is radial discharge. So that time VW2 will be perpendicular to the tangent. This one, this is the tangent is there. These things we have already discussed previously. Okay, so now to solve this problem, first let's write down the data given in this, and then we'll see how to calculate this. The solution, first we'll write down the data given. First line itself, you can see the overall efficiency is given, that is 75%. Overall efficiency you can write eta naught, this is 75%, or else we can write this is 0.75. Similarly, the power need to be produced is given. So how much power will produce, that is given actually soft power. So soft power you can write this is 148.25 kilowatt. Similarly, it is working under head is given, h is given, this is 7.62 meter. The peripheral velocity is given. So peripheral velocity, we know that is nothing but tangential velocity E1. So this is given 0.26 root over of 2 gh. So here we can put the value of g and h, we can find out the E1 value. So let's find out 0.26 root over of 2 into, this is 9.81 and this is 7.62. Then we can find out the value of E1. Similarly, the flow velocity is given at the inlet condition, that is VF1. VF1 equal to similarly 0.96, and this is root over of 2 gh also. Same thing, we just can calculate this with the help of by putting the value of g and h value. So this is, we can calculate this. Similarly, the next data is given speed. The wheel runs at the speed of the wheels given. This is 150 rpm. Okay, next is given the available energy. Okay, and the hydraulic loss in the hydraulic turbine are 22% of the available energy. So how much available energy is there, that we don't know. So we can write here how much losses is there, that hydraulic loss which is given here. This one we can write the hydraulic losses which is happened here, this one or in the turbine is given. This is 22% of available energy. Available energy. Okay, next one is yeah, these are the data are given here, and one more thing given, this is radial discharge, I told you. So radial discharge in the sense when the discharge in the sense outlet. Okay, so discharge is radial means we can write discharge at outlet, it is given radial. So radial discharge in the sense, as I told you, that we need to consider the VW2 is 0. Okay, and we can consider VF2 equal to V2. This VF2 equal to V2, because when it is 0, this value is 0, then V2 will become here. So here already this is VF2, so we can write VF2 equal to V2 here. Okay, now yeah, now what is given here, that 22% of available energy. So we can write, we know that we can write here that hydraulic efficiency equal to, we can write the total head at inlet condition, the total head at inlet condition minus how much losses is there. So how much losses happen? The loss is having 22% of available energy. So this one we can write, if you consider this one, like we can write this 22% of available energy or available head, we can say, divided by the head at the inlet condition. Okay, this one we can write in terms of like hydraulic efficiency. So similarly, H minus 0.22 H we can write, this is 0.78 H divided by H. So how much we will get here efficiency? This is 0.78. This is our hydraulic efficiency, we can write. Okay, and we know that formula of hydraulic efficiency, actually we can write hydraulic efficiency equal to, we know VW1 E1 by GH. When we can write this? When VW2 is 0. If VW2 is there, then we need to write VW2 plus into U2. Also we need to multiply in that. So this one actually 0.78. Now here we can find out the value of VW1. Why I have written this one? Because here we can find out the value of VW1 equal to, I can write this is 0.78 hydraulic efficiency into G value is 9.81 into H equal to 7.62 and divided by E1. Okay, E1 value we have not calculated till now. So we'll do one thing, we'll calculate these values of E1. So 2 into 9.81 into 7.62, this much, root over of this, multiply 0.26, 3.179. This one we can write 3.18 meter per second. So same thing I can write here, this is 3.18, and we can find out the value of VW1. We need to find out all these terms, VF1, VW1, E1 already given, so that we can able to calculate the angle. What is the alpha, what is the theta, we can calculate from that. So anyway, so similarly I can calculate the next terminology, this one VF1 also will calculate here. So this is also same thing, like 2 into 9.81 into 7.62 root over into 0.96, 11.73. This one we got here 738, so you can write 11.74 meter per second. So VW1 we can write this value. So let I can find out, is equal to 0.78 into 9.81 to 7.62 equal to divided by 3.18, 11.33. 335 we can write 11.34. So this one we got 11.34 meter per second. This is our VW1. Okay, now we can find out the value of guide blade angle at inlet condition. So guide blade angle at the inlet condition, that is nothing but alpha, this one, and this is vane angle theta. So first one, let me write here. The first point we can write tan alpha at inlet condition, tan alpha equal to what I can write in a VF1 by VW1. VF1 by VW1. So here VW1 we have calculated, VF1 also calculated. Alpha value need to be identified. So alpha we can write, this is tan inverse. This is value of VF1 how much? 11.73. 11.74 and divided by, this is VW1. How much we got? Yeah. VW1 11 point something, 18.34 we have got. So I thought both are same. Yeah. So this will be 11.34 bracket close. So now we need to find out this. Yeah. So we'll do one thing. 11.74 divided by 18.34. This equal to, and this one will go trigonometry tan inverse 32.62. So this is our angle 32.62 degree. This is our alpha angle. This is one answer we can write. Okay. Similarly, the next angle we can find out, this is, we can consider tan theta. Same triangle we can see. This angle, this triangle, tan theta. First one I have taken this triangle. Now tan theta also I can write same way, like VF1 divided by this value I require. This value is not given, so we can write VW1 minus U1 here to find out that. So here again I can write VW1 minus U1. Again same thing, theta equal to, we can write this is tan inverse. What we can write here, like 11.74, the value of VF1 divided by VW1 how much? 18.34. So 18.34 minus U1 is 3.18 bracket close. Now again same thing, we can find out the value of this. So let do one thing. 11.74 divided by bracket start 18.34 minus 3.18 bracket close. This much. Okay, 0.77 something is there. Let tan inverse of this 37.75. So we got here 37.75 degree. So this is the value of theta. So this is the first answer, we can say second answer. First answer, second answer we have completed. Now we'll go for the third one, which is given diameter of the wheel and width of the wheel. So these things also we can calculate, but we need to go a little bit lengthy. So first one, diameter of the wheel, the third point we can write. The D we can write, we can identify from the formula of peripheral velocity, that is U1 equal to pi dn by 60. We know this formula. So you can write D1 equal to U1. What is the value of U1 we got? We got 3.179 into, this is 60 divided by pi into n value, how much is given? N value given, yeah, this is 150 rpm. Okay, this is 150 rpm. So we can find out this how much. Let solve this. Yeah, 3.179 into 60 divided by bracket start pi into, this is 150 bracket close, 0.40, 0.4047, 0.4047, this much meter. Okay, this is our diameter. Now the last one is width. So width of the wheel at the inlet condition is nothing but B1. So here B1 formula we won't get directly, because we know that from discharge only we can find out the value of B1 here, because here area into velocity is there. So area we can write pi D1 V1 into VF1. Now in this equation, if you see, D1 already calculated, VF1 already there, pi value known, V1 is known, unknown, and Q is unknown. Now if you are able to find out the Q value, then we can calculate the B1 value. So to find out the Q value, again we need to go reverse, like we need to go for the overall efficiency. The overall efficiency value is given here, and this is nothing but soft power divided by water power. So soft power value is given already. So this is nothing but, we can say this is 148.25, which is given in our question, and this is water power. Now what I'll write here, water power we need to find out again. So water power equal to, we can write this is 148.25 divided by this water power. I can write the formula rho GQH divided by 1000. Actually this is water power formula. Okay, I have written directly, that is nothing but W into H. So in place of W, this is actually, I have written in this way, W by H 1000, in place of W, mg. Mg is nothing by written rho GQ, then H by 1000. So now here what I'll do, the overall efficiency value, it's given in the question 75%, that is 0.75 we can write. So this is 0.75 is equal to, we can write 148.25 divided by, this is 1000 into 9.81 into Q value into H. H is given how much? 7.62 is given. Now divided by 1000 here. 1000 will be cancelled. So here what we can write, the Q value, I'll take it to this side. Q equal to, we can write this is 148.75 and divided by 9.81 into this is 7.62 into 0.75. So let's solve this. Yeah, let's make it 0. 148.75 divided by, bracket start, 9.81 into 7.62 into 0.75, bracket close, 2.65. So here we got the discharge value 2.65. What is the unit will be? Meter cube per second. We need to remember that. Now just put this value in this equation so that we can find out the value of V1. Now we can write V1 equal to Q by, the whole term will be there, that is 2.65 divided by pi value into D equal to 0.4047 into pi D VF1. VF1 we got in the last one. VF1 is how much? VF1 we got 11.74. So write this value 11.74. Then we can find out the value of V1. So V1 equal to, we can write, so 2.765 divided by, bracket start, pi multiply 0.4047 multiply 11.79, bracket close, 0.177. So this is the width, 0.177 meter. This is our final answer as per the question given. So this is one answer. This is one answer. The formula we need to remember. Okay, what are the formula I have written? This formula we need to remember so that we can easily find out. Okay. Yeah. This is 2 and this is here 2 questions, 2 answers are there. This one and this one. So I hope you understand this problem, how to solve it. Only thing is we need to know the formulas and we need to find out the data given from the question. Based on that, we need to draw the diagram. The diagram is very much important. Though this diagram I have taken from the book, but we need to draw the diagram, the velocity triangles. Then only we can able to identify how to calculate. Because how I know the 10 alpha, how to take 10 phi, 10 theta, how need to calculate. By knowing this velocity triangle, then only I can able to solve it. I hope you understand the problem. Still, if you are having doubt and query regarding this, you can give a comment on the comment box. Thank you.